Hey everyone, so today we're going to start talking about inequalities. So there's a couple of things that we first need to note about inequalities before we can get started with graphing and solving them. And the first thing is that we want to talk about the notation or the different symbols that we'll use when we talk about inequalities. The first thing is our interval notation. Interval notation is another way of expressing the answer to an inequality. We're going to use parentheses and brackets to show where the graph starts and ends. So basically, we're using these two different symbols. We have our parenthesis and our squared bracket. And we're going to use those two because they each mean something different. When we think of an interval, that means where our numbers start and where they end, or where they go to. So when we think about these symbols, we have an open circle, or when we are not including something, so that would be like our greater thans or less thans. So my open circle means that it's not included, and we're going to use just the parenthesis, just kind of a small little buffer to say that this is where things are not included anymore. However, we use the bracket to say when some things are included, or we have a closed circle. That means that we are using the less than or equal to, or greater than or equal to. So we have our greater than or equal to, less than or equal to as our brackets. You can think of the bracket as saying this is my included. Think of it as like a little symbol hugging those numbers. They are included. So with that, we're going to just solve a couple of these and graph them on our number line. So when you graph these, we're going to want to first figure out where we want our graph to start from. So by doing that, we need to solve this expression here. To solve this, we need to get x all by itself. Well, to get x by itself, I see that I have this 4 outside this parenthesis. That means that I need to distribute it to both terms. So I need to take 4 times x, which would give me 4x, and 4 times 3, which would give me 12. And I still have this negative 24 over here. Now, I have 2 terms over here on the side with x, but I only want x to be by itself. So I need to get rid of this 12 since it's not a like term. And to do the opposite of adding, we're going to subtract 12 from both sides. So we'd have 4x is greater than negative 36. But I said I don't want 4x, I want just x. Since I have 4 times x, I need to divide both sides by 4. This one would be a little bit trickier. However, the 4 is positive. And since our 4 is positive, that means that we're not changing our sign. Just because our number on this other side here is negative doesn't mean that our x needs to change. So if I divide both of those by 4, we get x is greater than, well, negative 36 divided by a positive 4 would give me a negative 9. Now to double check this, we can take any number that would be greater than negative 9. Well, that means we can take any positive number or any negative number that is negative 1 to negative 8. So let's just pick 0. I like picking that x is 0. And we'll plug it back in to our equation. So if I take 4 times 0 plus 3, it should be greater than negative 24. So 0 plus 3 would still give me 3. So 4 times 3 greater than negative 24. And we know 4 times 3 is 12, which is indeed greater than negative 24. So that checks out. We did good. This is our solution for this problem. So now we go over to graphing and writing that interval. So when we write our graph, we want the number that we said x is greater than or less than to be the very middle part. So we'll put negative 9 in the middle. And as we move to the right, those numbers are going to get bigger. So negative 8, negative 7, negative 6. And as we move to the left, they get smaller. Negative 10, negative 11, negative 12. So I have my numbers put in. Now the tricky part comes with knowing what type of graph to draw with this. So if I have x is greater than, that means that we said all the numbers greater than 9. So we know we're going to be going this way to the right, where numbers get bigger. But this is not equal to. So that means that 9 is not included, and we're going to use that open circle that we talked about up here. When that number is not included, or we're using greater than or less than, we will use the open circle. So we have our graph done. Now we need to write our interval. Our interval tells us that we start at this point and we continue on in one direction. Now, our interval, we said, starts at -9, and it continues to go to the right forever. It never stops. We don't have any upper limit, as we call it. It doesn't have a stopping point on the higher side. That means that we go to infinity. Now, this is where our brackets come into play. We said that since 9 is not included, we use an open circle. That means we're going to use a parenthesis. But infinity is a little bit tricky. Because infinity is not a specific number, it just tells us the direction something is going, we can't necessarily say that infinity is included or not included. So whenever we see infinity, we are always going to use a parenthesis. So whenever we see infinity, we'll close it off with a parenthesis. Does not matter if it's positive or negative, because it's not a specific number. It is a symbol that tells us the direction that we are headed with that number. So if you would like to try, you can give these other 3 problems a try. I will be posting the key to these on our Schoology page. And the next thing we're going to do is talk about linear equations on a graph when we use x and y, and we have more than one variable in our equation. What does that look like? So talking about linear inequalities and being able to graph them means that we are given more than one variable in our equation. We're given 2 specifically to do our linear graphing. Normally they're going to be x, y, but know that you can kind of substitute either one in for any other equations you're given. So the first thing we want to do is define linear inequality and a solution to a linear inequality. And a linear inequality can be defined as similar to linear equations, but instead of using an equal sign, they use inequality. And so our inequalities are greater than, less than, greater than or equal to, less than or equal to. And when we talk about the solution to a linear inequality, when we talked about it for a linear equation, a solution was a specific point on our line or on our graph that that line would cross through. However, a solution for a linear inequality is all ordered pairs that make the inequality true. So that means that if I'm given an equation, it's not necessarily the line that is going to have an ordered pair. It could be one of the points in the shaded region of my graph. So anything that falls into that interval that we were just talking about would fit as an ordered pair. So first, let's just test out a couple of ordered pairs with an equation that we are given. So for this one, we want to know, are these 4 points going to be a solution to this inequality that we were given up here? Now, the nice thing is that we were already given points, and I'm not trying to graph anything right now. So I can take and just plug these points into my equation and solve and see if the inequality is true. So let's first try with 2 and 5. So this is my x, this is my y. So I would take 2 and plug it in for x, and then I would take 5 and plug it in for y, and I want that to be less than 15. Well, 2 times 2 is 4, and 3 times 5 is 15. And 4 minus 15, I'm subtracting a bigger number, so we're going to be negative. So I have negative 11 less than 15. Well, is negative 11 less than 15? Yes. Therefore, this is a solution. For the next one, we're going to do the same thing. X, y, plug them in. 2 times negative 1 minus 3 times negative 7 is hopefully less than 15 if this point is going to be considered part of our solution. So we have 2 times negative 1 to get negative 2. This is a negative 3 times a negative 7, so we can write that as plus 21. Is hopefully going to be less than 15, but if I take 21 and I subtract 2 away from that, I get a positive 19. And is positive 19 less than 15? Well, no, it's not. Therefore, this is not a solution. Again, we can try this next one, x, y. So we would take 3 and plug it in for x, 2 times 3 minus 3 times negative 4, hopefully less than 15. Now, if I take 2 times 3, I get 6. Negative 3 times a negative 4 would give me a positive 12. And we want that to be less than 15. Well, 6 plus 12 is going to give me a positive 18. And while it's smaller than 19, it's still not smaller than 15. So these 2 points in the middle have not been solutions, but our first point was. Let's try plugging in 0, 0 and see what happens. If I take 2 times 0 and I subtract 3 times 0, it's hopefully going to be less than 15. Well, 0 times anything is 0. 0 times anything is 0. Less than 15. 0 minus 0, still 0. And is 0 less than 15? Yes, it is. Therefore, 0, 0 would be a solution. Now, you might be thinking, how can I tell by looking at a graph what these solutions are going to be? Well, in order to do that, we have to talk about how to graph that linear inequality. So we're going to talk about the 3 steps that go into graphing these inequalities. The first thing we want to do is, just like with our linear equations, we want to make sure that we are in slope-intercept form for our graphs. Now, we want to be sure to flip the inequality if we multiply or divide by a negative number. If that number is negative, we are going to switch our inequality. So if it was greater than, and we multiply or divide by a negative number, this now gets changed to less than. Now, that's not to say that if I had 4x less than negative 10, and I divide both sides by 4, well, that's a negative 10, that counts for flipping. Unfortunately, it doesn't count for flipping that because I'm not dividing both sides by a negative number. If these were both negative 4, then I would flip the sign. However, for right now, we would not if they are all positive. Okay, so that's step 1. Step 2 is we want to graph the line. Same thing that we have been doing. You're plotting those points and drawing a line through it. However, we're going to use a solid line for greater than or equal to, less than or equal to. Just like when we talked about our intervals, the equal to means that that is included in our solution, so the line needs to be counted as well. But if we are going to use a dotted line if we're talking about just greater than or less than. Because we're not including the solution that we get, it has to be either greater or less than the number we're given. And the final thing is we're going to have to shade. This tells us where all of our solutions lie. So we're going to shade above the line if we have a greater than or equal to. This means that our y values should be getting bigger as we shade. Now, we're going to shade below the line for less than or less than or equal to, which means we're going to shade for y as it goes down when we have less than or equal to. So let's practice with our equation here that we were given. So if I have 2x minus 3y is less than 15, well, the first thing I need to do is put this in slope-intercept form. So that means I need to solve for y. So we're going to subtract 2x from both sides, subtract 2x. So I have negative 3y is less than negative 2x plus 15. Now, I'm going to get y by itself. I don't want this negative 3 being multiplied on. To undo multiplication, I have to divide by negative 3. And I have to divide everything by negative 3. Well, we talked about earlier, if I'm dividing by a negative number, I need to flip my inequality. So I'm going to do that now. Flip it so I don't forget it. And I'll have just y on this side equals a negative divided by a negative will give me a positive. And 2 and 3 don't simplify into anything smaller, so we have 2/3 x. And 15 divided by a negative 3, well, the negative beats out the positive, so we have negative 5. Okay, now let's give a go at graphing this. We know that the final part of our equation is our y-intercept. So that means on our y-axis, we can plot the point at negative 5. So 1, 2, 3, 4, 5, just enough space. And my slope tells me my rise over run. So that means I'm going to go up 1, 2, and over 1, 2, 3. So that would be the next point on my graph. So now we need to fill in, is this going to be solid or is this going to be a dotted line? Well, we don't have equal to in our inequality, so that means we're going to use the dotted line. So we're going to come through with a nice little dotted line. Make sure you include your arrows because that tells us that this graph does continue on forever, even if it doesn't show on our graph itself. Now, the key here is I have the sign greater than, and I have my y as being greater than. So we are going to be above our line when we shade because we're specifically saying that y is greater than this part of my equation. That means that as my y-axis goes up, I would still have points that are contained in my graph. So I'm going to shade this region up here. If this had been written the other way, we would have had something like 2/3 x minus 5 would be less than y. So you might think that, oh, that means it's less than, I need to shade below, but we're specifically talking about our y value. And we're saying that y has to be bigger than our equation. Our equation gave us this line, and since y needs to be bigger, that means we need to shade it up. As y values go up, our graph should be shaded. So if you have any other questions on this, you can certainly ask me during our class time, ask me during our Google call, shoot me an email, a message on Schoology, whatever it might be. Just let me know if you have any questions, comments, or concerns.